Hello, good evening, everyone. I would like to remind you to start with R or R Studio. So now I think I would like to share my screen with you. Okay, thank you, Parveen. Already been provided the link and preparing everything. And then good evening, everyone. So today we would like to a little bit try to get back what we already learned yesterday. So I would like to start from the file I already sent to Parveen, which is about revised dataset 1. Have everyone got the file or not yet?
I have shared it.
Okay, thank you very much, Parveen, again. Okay, if you already have the files, and then I would like to ask you to open, which is the revised dataset 1. We would like to start from that one. And then we will move to the next dataset 2nd, and then dataset 2nd B. And then the last one will be dataset 3, which is a different dataset from NCBI. Okay. I'm sure all of you already installed the bioconductor. So I think we just start from line 9, which is we call the library. We already installed yesterday. So let me run this one. I would like to make my screen a little bit, okay, try to make it balanced between the left and the right side. Okay, I think this is okay. Yeah, thank you. So now we call the library first. This one, the most important is the all package, which is line 11 here. So geostat, this is for hypergeometrics. Okay. This one and this one. Okay, now we read the data which is already been in R. So just like this. So if you would like to know about what is this data set, the class of this all data set, we just click it, and this is expression set. And then here we go, okay. And then after that, we also can try to know about the summary from the phenotype of this data set. You can see from here, okay. If you would like to know about this, what is the ALL dataset, and then you just type question mark and then ALL. In here, okay, we just run this one, that's okay. So you can see from here, which is on the right side, on the bottom of the right side of your screen, which is RStudio screen, there is information about this data set. We already learned about it yesterday. And if you would like to know more about the variable label in this data set, so you just click or run line 24 here. Okay, so there is information about the gender, the age, and other things as well. And there is also in here the class about phenotypics in his data frame. If you would like to know the inside of this phenotypic data set, because if it is too big and then maybe it is not good. So we have tried to know about the dimension of this phenotypic data sets. So here is 128 and in row, and the column is 21. Okay, and then this phenotypic information, but because of this is a little bit bigger, 128, so this is omitted 81 line, but that's okay. We don't need to do this one because I already explained yesterday. So I just want to make sure that the script that I already shared with you, this is working, so it is easier for you if you would like to do the same thing later. Okay, so this one we are doing just seeking the subtype, which is L1, F4. Okay, and then in here we start to do subsetting. So we just need to take 79 samples. Actually, there are 128, but you just need 79 samples. Okay, this one. Okay, so here we go, our data set. See. Okay, we just want to make sure everything is okay. I just follow this line. So this one here. Okay, so after this one, actually, if you don't want to do this, that's okay as well. But because I want to pick just some of them, so that's why we are doing subsetting. But if you're not doing that, that's okay as well. So the first one, we need to remove the gene that have no entries gene ID in here, okay? There you go, so we have this one. So you have to remember that the environment for this all data set, this is AGU 95, and then there is some other thing which is 133, and also there is 150 plus second, something like that. So you have to be careful, especially when you are taking the data which is from some public repository. Okay, so this is the entrance ID you already have in here. Okay, so at the end, we really remove the gene with has no entries gene ID. The last one will be okay. Okay, the second one, we would like to remove the gene which is no GO mapping. So we have to use this one. Okay. Okay. Now we would like to do some filtering. The first one is non-specific filtering, and then later will be specific filtering. Okay. In here, we are using interquartile range, and the cutoff is 0.5. If you would like to use the cutoff, for example, 0.7 or 0.75, that's fine as well. Okay. Yeah. Okay. This one as well. This is because of the situation or condition in this data set. There is imbalance of between men and women group. So we have here. Okay. So the last one, this is you remember the first one, which is our data set about ALL. Okay. This is not run, but okay, about 12,625 in here feature. And then after non-specific filtering, we already have 4,026. I think this is a lot better than the previous one. Okay, and then now we would like to filter the duplication. So we need to use the gene filter in here. Okay. Okay. So now we already have about 3,400. Okay, just to make sure. This one maybe you don't need to do this one, but if you want to, that's okay. Okay. And this one, we would like to define the gene universe based on result of non-specific filtering. Okay. So we are doing this, the feature name from the last dataset. We have this one. Okay. The second one is alternate for universe. The first one is gene universe, and then this one be based on the entire sheet. If you don't want to use this one, that's okay as well. So you just, for example, just like you use the universe one, it will be okay. Okay, because we already done the filtering, and then we would like to move to another step of analysis. And here we would like to use differential express gene and then also gene ontology. Okay, for differential express gene, okay, we have in here the cutoff for t-test. This is about 0.05 or 5%. I already told you if you would like to use, for example, 1% or maybe 0.1%, that's okay as well. So the cutoff here, we have to define before we are doing this one. Okay. If you have any question, what is small b all about? This is about the, how to say, the phenotypics that you would like to, how to say, comparing maybe the first one and the second one. If you would like to see about this one, so we have to go back to our phenotypic first, which is there is in here. Wait a minute. Here we go. We cannot see this one, so can we use just this one? Okay. Can you see in here there is information about COD, diagnosis, and then and so on and so on. And then we have information in here about mole bio, which is there is this kind of information. And we only want to compare two of them. So let me have this one. Maybe like this, summary. Maybe I shouldn't type it in here. I should type it up here. Summary, or not summary, it's like P data. And here, more.bio. That this will be working. Okay, so we can see that there is a level which is ALL 1, 2, 3, 4, 5, 6. That is 6 level, but we have already typed it before. Subtype is only ALL1, AF4. So in here we have only 2. That's why we are using this t-test. Okay, so let me continue this one, 154. Okay, so all of this here. T-test, this one. if you would like to know about what is the result of t-test, so you just type in here t-test. Okay. The same thing in here, if you would like to see what is the result in here. Okay, so here I have this t-test. So this one is about, you are doing the test for about 3,000, I don't remember, 3,400 something, I guess, or 3,140 something. So this one, the result, there are this gene, about 3,000 something. And this one, we try to select the t-test where the p-value is less than the cutoff. The cutoff is about 0.05. Okay, so in here we have about not many. So try to find out in here. Okay. This is logical, and then maybe you can have 3,400. Okay. Okay. After that, we need to how to say? We need to choose. We need to select the gene or the data set which is how to say related to this selection, because this is, we try to select the gene which is differentially expressed. We are using this comment here. So we got this one 667. You have to remember, firstly it was 12 something, and then it's become 10 something, and then it's become 3,000 something, and then after this differential express gene, we have this one which is 667. Okay, based on this, we try to know about the entrance ID of this one, of the final, the last result here. Okay, because maybe we cannot see all of them, so we just try to find the length of this one. You can see that the length is 667, and then now we are doing the gene ontology, which is maybe it is a biological process, molecular function, or maybe cellular component. In here, I am using the ontology for biological process. If you want to try to find this 667 gene about their cellular component, so you just type in this BP by using CC, okay? If you would like to know about their molecular function, so you just try to remove this BP and then type in here is MF. So this cutoff is about 0.001. Okay. And then I think before the BV and CC, I have to make sure that there is a package which is geostat and also category. Let's go back here. Have I called this library or not yet? Geostat, yes, but category is not. So I have to call them in here. Library. What is the name of category? Okay, you already have this one, and this cutoff here, and this parameter. Okay, okay. So now we are testing this gene ontology. Just wait a little bit. In differentially expressed, actually we have two types. The first one, three types, but mostly they would like to know about it is offer expressed or offer represented, or maybe underrepresented. In here for gene ontology, we would like just to use this offer represented or offer expressed. Just wait a little bit. Let me see the question. Okay. This one. Okay, so we have 115 the gene, the GOID based on the gene 600, this one, which is less than the cutoff 0.001. Okay. Okay. This one. Okay, wait a minute. Let me see the chat box here. Heat map has been covered, not yet. I guess we will have that one later. I hope so. Okay. So if we are using the conditional parameter, and then it will be only 62 how to say BPID, which is tested less than 0.001, the p value. And then if we would like to know more, it is possible you just type in as like this summary. Wait a minute. Oh, in here I couldn't show you. Let me try this better. Perhaps this one will be better. Okay. So this is the results you can see from here. In here is gene ontology or gene ontology of BPID, which is 0.0 and so on and so on. And then we have this B value 4.2 something, and in here is the offer minus, which is less than 0.00 something. And then this is the OR ratio, and this is expected count, and then this is count, and this is the size. And this one, the terminology is about cell-cell addition. Okay, so for example, we have in this 667 genes, okay, the gene, some of the gene which is related to this biological process, mostly in here, if it is the GOID is this one, and then it is related to cell-cell addition. I'm not sure how to interpret exactly in here because I'm not from biologists, but I think some biologists in here maybe can help me how to interpret more about these things, okay? So, but at least I would like to say that we already have about 12 something gene related with this ALL. But at the end, after some analysis, actually there are only 660 gene which is related to this disease, okay? And then from this 660 gene, there are some gene which is probably related to biological process, and then to cellular component, and also for the molecular function. But in this one, I just concentrate on to the biological process. So maybe which one is better to be further analysis for the next research. I think you understand more than me. Okay, so please help me as well, okay, to interpret about this one. Let's me go back here. The other one, I think that's okay. It is just the summarization from this one. For example, there are some column or something and in here and so on. And also, I think based on this one here, actually we have information. Here only 115. So this one, actually this is the gene, the biological process, which is having b value less than 0.001. Okay, so the other one, another one is about the conditional, which is we already have about 60 something. I think about 62 biological process related to the gene ontology related to the biological process, which is less than 0.001. Okay, if you have any question, please let me know. So I think I already have someone raising their hand. They would like to ask me maybe some question. Okay. Okay, there are some questions in here. Oh, mom cannot install Geostat. I think you go for the suggestion from Rohit Satyam, which is the last message from him. So the way you are doing this package, which is Geostat, I think Geostat should be with capital S. As long, oh, no. Okay. Yeah, that's right. Okay. So how do we select the significant GEO term based on probability value? It depends on how you select the cutoff. Okay. If you would like, for example, your cutoff may be 0.05. So at the end, after you are doing this hypergeometric test, all of this significant GEO term, it is less than 0.05. But in my case, in here, actually, I select the GEO term, which is less than 0.001. Okay. In statistic, actually, the smallest p-value is mean you are making a mistake really small. For example, 5%. You are taking the cutoff 5%. Taking cutoff 5% mean you are just making an error 5% when you are taking the conclusion based on your data. Okay, so 5% is mean the probability that you are doing type 1 error. So if you would like to make your type 1 error very small, so you can take smaller than 5%, for example, 1% or maybe 0.1%, something like that. So another question may be, what is the type 1 error? Type 1 error is the probability that your hypothesis, the probability that wait a minute, I have to write something first. So, and then I will get back to you. Probability of no is correct. Okay. Probability type 1 error is the probability that you reject the hypothesis null when the hypothesis null actually it is correct. Okay, that's type 1 error, because in here you are doing hypothesis testing. In hypothesis testing, you have type 1 error and then type 2 error, but mostly it is about type 1 error, which is you reject the hypothesis null when the hypothesis null actually correct. Okay. I'm getting this warning, trying. I guess maybe your R version may be less than 4 point something. I mean, less than the current one. This is differential expression analysis of yes. Okay. Okay, thank you, Alberto. Alberto said this is because you are doing that twice maybe. You already installed and now you would like to install again. You install it again. Okay, so this is the step-by-step when you would like to, how to say that, you would like to do the microarray data analysis. The first one is about differential expression and then gene set enrichment. Maybe I would like to highlight about the result from differentially expressed gene. We would like to see which kind of gene, okay, in here. So 600 something. Wait a minute, I have to go back up here. This one about before, so it has to be. Okay, let's go back here, which is line 162. This is about the p-value filter. Okay, and then you would like to see this gene. Okay. Okay, can you see that there is in here on the screen? You can see about something. For example, the last one is better. For example, in here, 35618 underscore 80. So this is the gene which is related to this ALL disease. Okay, and then the entrance ID in here is 9931. Okay. If you would like to know just one gene related with this disease, in gene ID, I think you just try to type the gene, the entrance ID, for example, 9931 in here. Maybe I should use another. Here. Nine 31. So I'm run here. This one. Yes, come back to here. Just right now. Okay, so in this case, this gene, which is the entrance ID 9931, they don't have BP. Okay, it is not, even if it is, for example, related to this disease, but this gene is not expressed in biological process. Perhaps maybe it is possible they are expressed on cellular component, or maybe in molecular function, or maybe not at all. Maybe they are not expressed in 3 of them. It is possible, something like that. Okay. Let's try to have another one. Or maybe we are using in here molecular function. It is possible. F. Just run. And then after this, we are going to here. Run. Okay. Just wait. Probably there is, probably not. Oh, they don't have as well, but that's okay. But at least you understand about the gene ontology. Sometimes the gene, it will be belong to a biological process, or maybe just 2 of them, or maybe 3 of them, or maybe none at all. Okay. Just a minute. Okay. There is no package category. I think category with capital C, not small c, okay? Try library and then with capital C. While running RStudio, error showing RStudio not connected with R. Really? Oh. I'm not sure why this is happened. Okay. Maybe you can check about your R version and also RStudio version. Okay. You're welcome, Ritwik. Okay, another thing about the Peno data, actually, it will give you also information about the data sets, because this is possible. The data sets is already been pre-processed, and then they put in the NCBI, and also it is possible they didn't do anything. In case of that they didn't do anything, so it means you have to do the pre-processing if you want to do that. But I really advise that you are doing pre-processing for your data set from NCBI. Okay, if it is not pre-processing. But if it is already been pre-processed, so you just need to to continue your analysis. And also you can ask about the raw data set. The raw data set mean that maybe you didn't the author or the owner of this data set they don't do the pre-process before, so you have to do the pre-processing as well. Okay. Can you try and explain the line of code? Yeah, which line, please? I already, would you like me to explain from the beginning? Or maybe you would like to know about from which line in here? From the beginning, okay. Okay, so the first one from line number 2 until 6, actually this explain about how to say installing the bioconductor, which is the core of bioconductor package. Okay, the second one, which is line 6, this is try to install some package. In here the package is about FE and this database and all NGOstat, Lima and R color brewer. Okay, so this is the way how you install the package in bioconductor for your data analysis. Number 7, I'm trying to give you an example how to do this if you would like to install just one package. So line 6, it is for many package, and here there is the difference between line 6 and 7. If there are many packages, so you just need to use this C concatenate, okay? And then if it is only one, you don't have to use C in here, okay? So after you install the package, before you are doing analysis, you have to call the package. So how to call the package? It is calling its library. So the way you are doing that, this is the way to call the library by using this library and then the package, okay, and so on and so on. Okay. In this example, actually, I would like to show you if we have already the data set in our computer. Later, in another script, I would like to show you how you are doing that if that's the data, for example, coming from different places. In here, I would like to use NCBI as a public repository data, but in here, we are using data which is already been in R. So the way you are calling the data, and then here by using data and then the name of this data, which is data all. This all data coming from all package. So that's why we need to install this package. So after we call this data, and then we would like to know the class. This is my habit. When I have the data, actually the first one, I would like to know the class of the data. Why I need to know the class of the data? Because it is easier for me to, to interact more with the data later. So in this case, we have this class of all data set. This is about expression set. I couldn't show you in here because we already been doing that before, but that's okay. Okay, and then after that, because I already know about the class of this data, and then I can call this data. And also I try to prevent, in case the data is really big, if I really directly call this data in this R screen, in this R console, it's maybe it is not convenient, because if it is big, and then we only can show just some of them, okay? And after that, I try to look at the phenotypic of this data set by using this one, okay? And then line 23 is mean I would like to know more the information about this data set, because this is already been R. If you would like to know some data set in R, so you just type the question mark and then the name of the data set. So this is happen in line 23 in here, okay? After that, I would like to know the variable labels of this data set, because this data set is about expression sets. There is a var label, there is about sample, there is about anything in there. We will show it later. So that's why in here, I would like the variable label for this data set. And this one is phenotypic. I would like to know the the class of this phenotypic this data set. Usually it is in data frame, but it is possible maybe in the new data set, it is not in data frame anymore. For example, maybe in table data set, okay? So if it is in table, and then the way I interact with this phenotypic data set will be different. Okay, so this one is, I would like to know 26. I would like to know the dimension, because previously it was data frame. If it is data frame, but I would like to know about the dimension of this data set. Again, I try to prevent, if data is really big, I don't want to show all of them directly in my screen or in my console. The dimension, I think about 128. The column, I don't remember exactly. Maybe about something, maybe 60 or something like that. We can get back that later. Let's just to click this data set. Data all class. This is expression set. You can see from there. If you're directly working with this kind of data set, it is not exactly the same with the other class data. For example, class data is numeric. It will be different from that one. Okay, and this one, okay. I already been told you that in this expression set, there is sample names, there is variable label, and also there is variable metadata. You also get information. There is 12,625 feature, which is the representative of the gene, and we have 128 samples. Okay, and okay, the variable label, it is about 21 in total. So this is about the phenotypic of this data. Let me this summary. So this is the summary. Actually, summary is not a good thing if you are dealing with this kind of data. Maybe it is better you are using this one, str p data. I think this is much better. But if you would like to summary, that's fine as well. Why I'm using this str? The str will give you information about the type of the variable in your data set, because we have 21 variable for this phenotypic data set. And then we can see, for example, for COD variable, this is, now I don't remember. What is, can someone help me? I don't remember. No, I'm sorry. Okay. I will tell you later. Okay. So for diagnosis variable, the same thing. Not characteristic. Yeah, this is a character. Sorry, this is character. Okay. So and then for example for gender, which is sex, in here is a factor. There are two kinds of factor in here, which is female and male. And then for age, it is integer. So it is impossible. You will find, for example, the age is about 28 point something, because integer is without comma. Okay. And then in here, BT in here also in factor. And then another one is in character. Another one is in logical. For example, false or true in here. The same thing with error as well. Why we need to know about this kind of variable in this data set? Because if you are using summary, this one, character, okay. If you are using this summary, the character maybe will not give you information about, for example, mean, median, and something, because this is not integer or numeric. If it is numeric, and then you will have the mean, median, the minimum, the maximum, and so on. But if it is character, or if it is, for example, like logical, if logical, so it will be only true or false. Okay, but some kind there is a missing value, and then this missing value in summary will be represented by NA. Okay, so you can see that, for example, in gender, there is an A3 data. So why this is happen? It is possible, for example, during the collecting the data, maybe the patient forgot, not the patient, I think the people who collect the data forgot to check the box about male or female. It is possible, something like that. And also for emission, there is an A, about 14 samples. And then for like KeyNet and MDR and so on, there are some missing data in here. Okay, so let's continue. Variable label I already explained. Number 26 already. Okay, okay. So 29 in here, there is one variable which is mol.biol in here, and we would like to know about this because we would like to see that later. So in here, for this variable, actually it is a factor. You can see also from here, number, there is a number in here. This one, this is a factor 6 level. Okay, do we use all the 6 level? Maybe yes, or maybe no. Okay, thank you very much. And then for this one, we are using this subset type, which is about AL1, 6, AF4, okay? And then in here, maybe we should try to use this one. For example, maybe you would like to know about this B cell. Okay. Okay, now what is B cell about? Okay, you can see that this B cell actually telling you about, there is information, for example, B in here, which is for all WBT. All WBT, we have to go back here, this one. There is information in here. This is a factor with 10 levels. There is B, B1, B2, and so on and so on. Okay, so this one, I guess this is, we just need to, how to say, to select, which is containing with this B character. This one, we just try to make it as a character because previously it is not a character, it is a factor. And then this one just would like to show the result, and we sell the same like before. Okay, in here we try to select the character which is negative in subset type. We already used the subset type in here is all 1 / AF1. So in here, we would like to use this negative one. So after all, we will have another data set. I will show you later. So this one, we already have, so maybe just run in here. Okay. You can see that the number which is represented in here, the number which is suitable with this kind of subsetting. Okay, and this one. Okay, you can see from here, the first one is about BCR containing in here BCR, ABL, or the, and so on and so on. The previous one, which is about 12,000 something, because of we are already subsetting this data set by using this one. So this subsetting actually depends on you. You want to select which one. Okay, so this selection it means the last data set will be only 11,400 something. Okay, so now we would like to see about the variable labels for the last data set here. So we have this one, information. Can you see from here? Okay, and then for factor of this one, the negative one, you can see from here, and this is the result. So in this case, we only have two kind of data set. Okay, so previous one, I already show you that the mole biol in here, I think about 6 or something. Let me show you here. Okay, the factor with 6 level. Okay, but because we already been subsetting about this one, and then we only have 2 level. The first one is this one, and the second one is negative only. Okay, but you also need to remember why this is reducing from the first one to this one, because in here we already how to say selects this one, line 65. Okay, in this line 65 we select something, which is why this is reduced into line BCR ABL. For mole biol, it is only 2 factor or 1 factor, but it is 2 level. Okay. Okay. 78, we try to remove the gene which is not having entrance ID, entrance gene ID. So it is possible that the gene not having entrance ID. Why this is happen? This is, I think, human error, because during the production, maybe they are doing something that we don't know, but it is possible. So the way we are doing that, the first one, we have to know about the feature from our data set, which is this one, BCR, ABL, OR negative. Okay. And then how we know that this is belong to, this is having interest ID or not? We remember that this one is human genome, this person. So human genome of this person, they have their own interest ID. So that's why we need to know, we need to put the environment in here, this environment. Okay. Okay. And then this one, we try to find the gene which is having interest ID. And this one is not having interest ID. And this one, we try to look at there is the gene which is having interest ID or not. And I think we already know the answer, which is 0. So all of the gene in here actually already been having the interest ID. Okay. So to make sure later we are doing this. And now we try to remove the gene which is no GO mapping. It is possible. Okay, the gene which is no GO mapping. If, for example, you don't remove this, you will end up having the gene which is maybe something like redundant. You already know this one is not having GO mapping, but you still insist to do that. And also, I think this one tries to make you easier to select the gene, which is the new gene not having GO mapping. But if you are knowing that earlier, so it will save your time and also your energy. Okay. Okay, this one we would like to do the analysis, and then in here we would like to filter. There are two kind of filtering I already explained yesterday. The first one is about specific filtering, and the second one is about non-specific filtering. This non-specific filtering, it can be from interquartile range. It is possible, for example, using, how to say that, the variance cutoff. And it is possible also, you would like to select some gene, which is, what is the name? Control probe. You have also to remove that gene. This kind of filtering is called as non-specific filtering. So what is the name for the non-specific, for the specific filtering? For the specific filtering, we will do it later. Okay, so this one for drop dose on Y chromosome or something like that, it is belong to this data set. In this data set, there are information about the Y chromosome between man and woman, and then this one, it is not balanced. So that's why in here they would like to drop it. Same like before. Okay. Filter the data. I think this is just the same like before. We try to find, maybe there are some duplication in here. Duplication, the feature, the name feature. So in here, NS filter by using interquartile range in here. And here we are using selected the second selection in here. Okay. Why we need this second selection? Because in here we are concerned the previous one, the first selection, which is just selected, not selected 2 or not selected 1. It is not the still including this chromosome Y. So the second selection actually removing the chromosome 1, the chromosome Y. So in here we are doing the second selection. Okay, why we still need this interquartile range result? Because this is like subsequent process. We cannot use that like the parallel one, but it has to be sequencing. So this first, and then the second one, and the third one, like that. Okay, this some color you don't have to if you don't want to do that. It is just like an additional something to make it maybe more catching eye if you are doing visualization. And then this one is define gene universe based on result on non-specific filtering. Okay, why we need to do that? I think because of, I already told you before, if you would like to know exactly, for example, in statistics, there is a local maximum or global maximum. If you would like to know about the this critical point is local maximum or global minimum, the global minimum we have to do, we have to check it by using the second, I think second derivative of the function. If the second derivative of the function is less than 0, so the critical point we already got, it is global maximum. Okay. But if we are not checking that one, we only can say that it is just local maximum or maybe local minimum. Okay, so this one, the universe one, I think it will secure you at the end of your analysis that this one actually you already, for example, comparing with all the gene in here, so it will be okay. And then the second one, it is just based on the entire chip. So it is possible as well. For example, this chip in the production of the company, maybe they only have this gene, not the universe one. And then there are another chip. This is containing also another gene and so on. And the whole chip in here, the production, it will not exactly the same like the whole gene universe, which has already been known by all of the people. Okay, so but it is still okay. It just look like local, national, or maybe national, like international, something like that. Okay, so line 154, we are doing differential express genes. This is actually the same like specific filtering, the same like that one. But in here, we are not talking about specific filtering yet. Okay, in here we have the cutoff. The cutoff in here, it is for the p-value. And we already know before that the mole bias from 6 level, we already been cut into 2 level. So that's why in here we are using row t-test. Okay, we are not using column t-test if it is column. So you just comparing about about sample. But in here, what we would like to investigate actually the gene which is related with this disease. So I already told you yesterday in bioinformatics data, which is from Epimetrics or from Illumina, row will be the gene, and then the column will be the sample. Okay, so that's why in here we use the row t-test. Okay, and the result will be in here. Okay, 158, it is just show you the p-value of the previous test, which is less than cutoff. Our cutoff in here is 0.05. And then this is just the class length. We just would like to know how length about this result. And then 163, this is about the filter. We try to take out, okay, the gene which is referred to 158, which is less than cutoff. If we don't do this 163, all of the gene which is not less than our cutoff, which is 0.05, will be still in there. But in this case, we already select the gene which is differentially expressed. So 158 actually showing you that this gene, which is less than the p-value less than 0.05, it is the gene which is expressed. Okay, overexpressed or maybe how to say that, overexpressed or underexpressed. Okay, 166. So we try to select the interest ID which is belong to 160. So that's why I told you this is the subsequent work. And now we are 170, line 170 and so on. It is about gene ontology. In here, I only use a biological process, but you can also use molecular function or cellular component. So for gene ID, I already told you it is possible, maybe only 1, 2, 3, 4, and something like that. But I think in here we are using all of the interest ID, which is already been tested, which is differentially gene expressed. Okay, do you have any question? Yeah, I really thanks to the expert in bioconductor, Professor James McDonnell. There are Professor Martin Morgan. There are also, I think, Dr. Levi Waldron and Professor, what is the name? There are some Professor Wolfgang Huber. There are many, okay? Yeah, Sean Davis as well. There are many experts, which is I really appreciate about their work. It is really help us if we would like to analyze the data. Okay, how to add molecular function? Okay, it is, can you see line 174? In 177 or 74, there is ontology BP. If you would like to molecular function, so you just a molecular function, it will be MF. If you want to know about the gene ontology of cellular component, it is not cellular function, I guess cellular component of your gene, which is already been differentially expressed, and then you just type CC in there. Rohit, yes, how can I help you?
So Rohit, you can ask your question.
Thank you, sir. So, ma'am, I was wondering when you tried doing hypergeometric test using a single gene ID. So, like if it can be, please correct me if it can be done with single gene ID, because we were seeing there were 0 genes having the significant p-value. So what I think is there should be at least 7 to 10 gene IDs to perform hypergeometric test,
Oh, okay.
because it's a enrichment analysis.
Oh, yeah. Okay. I'm sorry. Yeah. Okay. Thank you very much. Okay. I think Rohit remind me that actually when you are doing this kind of gene ontology, it should be more than 2. He said that at least 7 or something. Thank you very much, Rohit. Okay. Yeah. Okay. Okay. He already answered that question by himself. Okay. Okay, Dr. Sid, do you have any question? Because you asked me to explain it one by one. Okay, I guess it is okay for the first data set, and now we are going, no, you don't? Okay, thank you very much. So now we are going to the second data set, which is coming from NCBI. So in here, I just close this one. I add something, but it is not very important. Okay, now going to dataset second. Okay, if you want to use dataset second B, that's fine as well. If you want to use dataset just second, that's fine as well. I'm using this one, actually both of them using this GSE 10072, but for B, I directly taking the phenotypic data by using online, online facility by using the GEO query package. Okay, but for dataset second, which is without B, actually the phenotypic data already been downloaded by me. And then I try to cut off some information in there, so it is easily for me to use it. Okay, which one do you prefer, dataset 2 or dataset 2B? For me, anything is okay. 2 normal, okay. Okay, this one, the dataset. This one, some package which need to be installed before, okay, but I think this one is too many. But because I used it before, so I didn't select some of them. But I already select the library, for example, line number 9 and also number 12, because we don't use it in here. Because this GSE 10072, they only use this line number 10 and also line number 11. So that's why I already giving the hashtag in here. It means we don't use it here. So FE, I already have it, but that's okay. We will, I try to move this one. Now I forget how to make it, maybe Control-C, I don't remember. No. Actually, I try to clean my, my console, but I forgot how to do that. Control-C or Command-C, I don't know.
Ma'am, there is a broom broom icon present in the console, top right corner.
Oh yeah. Okay. Where is that?
Broom. This is highlighted.
Okay. This one. So it will be. Wait a minute. Control. Yeah. Control L. I forgot it. Okay. Thank you very much. Okay. Okay. So this one will be library FE, the first one. Okay. Just click this one. This 23 actually we don't use it in here, but that's okay. Even 22, we don't use it as well in here. Okay, so in this case, I already download the dataset, which is in this folder. Okay, you can see in here. Maybe I can show you my download. This one. So this is my dataset already been in here. No, you cannot see that because I don't share my file as like this. Wait a minute. Okay. Now I think you can see that. So this is the dataset which is in my download folder in here. So all of them is already been in here. And then after that, I just try to read or call the dataset. This here run. And then in here, read FE. Okay, as usual, because this is FE matrix dataset. And then this one, a little bit slow, that's okay. Okay, in the meantime, I would like to show you, okay, it's okay. So for this data set, you see, this is FE batch object, okay? So if you would like to know more about this one, so we can have it later. Here, for the phenotypic data set, I already downloaded before by using the command maybe in dataset subi, but we still not using this one yet. So I have already this phenotypic data in my other folder, which is in download, decode live workshop, RSession fix, and Parupi data set. I already send you as well. Okay, so in this case, because I already have it in there, I just read it. If you would like to know more about this phenotypic, you can see that this is kind of annotated data frame, the class of this one, okay? So now, because I already have this data, phenotypic data set, so I assign this phenotypic data set into my data set, which is for GSE 10072. Why I'm using this one? Because I would like to make it easier for me, okay? If, for example, you say, for me, it is not easier, it is better, for example, using the whole phenotypic data set from how to say, from the owner, that's fine as well. Okay, so in this case, it is make me easier. In this case, just run like this one. Okay, now we would like to see this phenotypic data set of GSE 10072. Okay, see from here. So for example, the first sample in here, this is coming actually not organism. It has to be not like this, but I'm taking that as organism. This is having adenocarcinoma of the lung and the gender female, and at diagnosis S74, smoking. It is not smoking, never smoke. And then the stage of this carcinoma, it is about 1B. And then stage this one. You can see from here there is 1B and 1A, but for just stage, this is only one. You can also see from here, for example, 3B, 2B, and 2A. For the stage, it is only 2. Okay. Okay, so PENA, and then this call name of the phenotypic data set. This is about organism, gender, and so on and so on. We already seen that before. So now I just want to make it this data set becoming all data set. It is also for me to make it easier. So this one, you see, this is FE batch, still 22,000 something, okay? And the sample is 107. In this case, the type in here, I only use adenocarcinoma in here and then normal lung, okay? So in this case, I just want to choose this kind of, how to say, groups in here, maybe for the next analysis. If you don't want to use that one, for example, you want to use the other one, for example, like smoker or non-smoker, you can use that one as well. Or maybe you want to use male and female, you can do that as well. Or for example, you want to use this stage, which is 1, 2, 3, 4, that's fine as well. But in this case, I just choose this one, the situation that I would like to compare between adenoma and then normal lung tissue, okay? So just run this all the way here. This means you try to make it the data set as you like. Depends on the research question of yours. So in my research question in here, actually, this is about comparing adenocarcinoma and the normal one. Now we are doing pre-processing, but actually this data set already been pre-processed. We know about that information from the phenotypic data if we are doing that online. So why I'm still doing this processing in here, I think I just want to show you how to do the pre-processing, okay? Just why this one. In here I'm using RMA, okay, and normalized quantile, and then the summary method is median polish. This is a little bit long, that's okay. Thank you, Isaac. I forgot it before. Sufyan also, yes, thank you. Okay. Thank you, Alberto, that the link for this dataset from NCBI. Okay, let's continue. The same like before, I like to have to know about the class of my dataset, still like before. Okay, so this one still like that one. And now we are doing filtering, okay. In this filtering, you can see that actually I excluded the feature which is containing this suffix, okay. And then the variance cutoff, it is not 0.5, but in here is 0.75. And then I also want to remove the entrance ID, which is duplicated. And also this one I said require entrance. This is my data from the previous one, which is coming from pre-processing. Okay, so you just click this one, run. Okay, 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 okay. So filter mean we already have the data which is already been filtered. The first filter is in line 54 until 56. Okay, so now we have the expression set as like this. Okay, now it's already been matrix or array. Previously, it is in expression set class, but now it's already been in matrix. If you would like to see this one, you can just maybe, how to say, dimension of this one. Because if it is too big, and then we cannot see that properly. Okay, can you see that? Do you remember what is the original gene of this data set? Do you remember that? The original gene of this data set. Anyone would like to give me the answer? Maybe you can just type it in the chat box. Before filtering. So this 3161 is after filtering. But before filtering, how many? Do you remember? No? It's about 22 something. Okay? 22 something, 20,281. This one, 22,283. Okay, thank you very much. Okay, after the filtering, we got this one. So now I think we need to continue here. Oh, where is, okay, my filtering in here. Okay, so this one, we just continue. We try to make it the filter as an expression set. Okay, we try to make sure that row name, the phenotypic data equal with call name of this expression set. If you would like to know about the call name of this expression set, so you just here, call name exp. See, so this is the call name. But for the phenotypic data, it will be as a row, not as a column. So this one, it has to be to make sure if it is, for example, false. So there are some information maybe wrong in here, and we have to be careful. But usually no. But we just to make sure, okay? And this one, we try to how to say that to define the new experiment data. Okay, and this data will be the new expression set here. You have to remember that this data set for the annotation is this one, not 95. Try to remember that one. Okay, so now the same like before, we remove the gene that have no interest gene ID. Even we already done that before in the filtering, but in here we try to make it sure. Okay, the process the same like before. Okay. Yeah, the same like before, geomapping, the same like before. So that's why I told you that I just want to show you how to do that if you are having the data from public repository. So now non-specific filtering in here. Okay. Okay, the same like before. You don't need to do this one. This is me. I want to check it before. And this one. And this one, the same like before. Okay. Okay, the same thing like before. So once you already know about this, I think the next one will be okay. This kind of process actually will be applied as well to RNA sequencing, which is for sequencing dataset. But the way how to access the data and the way how to interact with data, it will be a little bit different, but the process still similar. This will be the same like before. You can see, I try to make it here. Okay, now this different, this is should be now because this is Peno, I already know it before. So now this is about the differential expression. Try to remember how many our data our gene before, 22, and then becoming something. Okay. Okay. 3,400 now becoming 3,100 something. Okay, the same like before the interpretation. Okay. Okay, so now this is the same like before, geostat and category. Actually, I don't have to call the library as well in here, the geostat and category, because we already, how to say, call it before in the previous exercise. But in here, because I, how to say, want to show you, maybe you use it just one, each type, each file. You are, for example, running it maybe different times. So that's why in here, I'm trying to call it again. The cutoff is in here 0.001. Okay, the same like before. You just need to be careful in here and also which one in here and then in here as well. Other thing will be the same. Okay. So, that's why. For dataset 2B in here, the step will be the same like the first file and also this dataset 2. But the difference is we didn't know about this phenotypic dataset, so that's why we have to how to say, to mining about that information online. I already also overcome the difficulty yesterday. I already told you, I asked my colleague at my university and he gave me the information how to solve the problem. So that's why I would like to show you in here. Okay, you can see that there are 7 which is less than 0.001, and then this one is still in process. Yeah, this one is just another result presentation, but we already know that previously. Are you going to provide this data? You can download it. I think Alberto already showed you the link how to download about this file. This one, NCBI and LM.nih.gov. You can just click this one and then download it from this website. If you don't want to download it, I will show you later. Okay, so that's for the first and the second file. So now we are going to the third file in here. If you don't have any question, I will directly continue to the third file. But if you have question, please let me know. So anything will be similar with the 2 previous one, but the difference is in here. Okay, this one. If you would like to get your data online, you can use this one, which is line 31 until 34. So in this case, you don't have to download this data set. Wow, actually 8 GB for RAM is really, really good. Wait, I should ask you, your computer is Windows or Apple? If it is Apple, 8 GB is really okay. But if it is, how to say that, Windows, sometimes there are some difficulties. Yeah, okay. In Windows, sometimes, yes. I don't know how to solve that one. Maybe maybe you need to remove some of application. Usually biologists, they have many applications. You have will be Megan, Mega X, class, anything. I think that I have some friend from biology, they have many software in their computer. Okay, wait a minute. Can we allocate that RAM to RStudio? Alberto explained to you that usually web browsers saturate the RAM. Yeah, if there are many software in your laptop or computer, it definitely will take, how to say, will eat some of them. So you have to remove, or you maybe you need to remove your software into something like outer disk. When you use it, when you would like to use it, so you have just to make it sure, take it back to your laptop. Samsu said, try to close your browser. Really? Okay. Try to remove RBase and Studio and start the latest version. Okay, that's very good. Thank you. Oyedele, if you would like to have some question, yes, please.
Okay, thank you very much, Ma, for a good presentation.
Okay.
But from my own area of concern to me, because looking, I will suggest, because yesterday I tried running some of those scripts on my system, I'm getting error. I don't know what is wrong.
Yeah.
And today, and I would suggest, like for today, if we can have a particular zip file containing the whole project, so that we can easily follow along alongside with the data sets, so that it will be easier for us.
Okay, actually the file already been sent by Parvin in WhatsApp group, right? Parvin? I
Yes.
think yes.
Yes.
Yeah.
Yes.
Okay, thank you very much. But I'm not sure, maybe, how to say that? Oyele, maybe he didn't join the WhatsApp group yet. If you didn't join the WhatsApp group, I advise you to, to join the WhatsApp group. You can have more information in there, I think.
Thank you, ma'am.
You're welcome. Okay, if possible, please provide. Yes, we already sent it. I think the organizer also already sent it. How do we learn this comment from Bioconductor website? Okay, from Bioconductor website, it is not exactly as like this because it is depend on you are doing what data analysis you are doing. But usually, I think you can go through. There are some courses in Bioconductor website. I think since 2003 until now, 2021, yes. You can browse all of the material in there. Okay, but what are you doing now? It is just for microarray data analysis, and it is for this one is gene set enrichment, and also for differential express gene. If you would like to do the classification, I provided in the third dataset. No, the third file, and the third dataset, the fourth file. We will do it later. Please share WhatsApp group link in here also. Maybe Parfin, he can that. Okay then, yeah. This one, if you would like to directly get from the website, which is line 31 until 34, and then now we try to get this phenotypic information. Previously, I was failed, and then I asked my colleague, and he told me to do something like this. I hope this will be working. So now I'm really would like to know if it is working or not. So this one, I'm trying to read and call the data first. I forgot to use the broom, but we'll be do that later. So I think it's better using this broom. So now run this one. And now I read my data set by using read EPI because this is coming from EPI Matrix platform. For Illumina, maybe you can use like bit array package, or maybe you can use like Lumi package. So there are some, some choice. So it's depend on you which one do you like. Okay, so this one, this is EPI batch object. You try to remember another two data set or another two file, the same thing like before. So I don't use this one because I already have it in my computer. But if you want to try at home, it's okay. So now I would like to know about the information about phenotypic of my data set here. Okay, so I'm using this one multiply to 5. Previously, I'm using multiply to 3. It was failed. And then 4, it was failed as well. And now 5. If it is now 5, for example, failed again, maybe I have to increase that one. Okay, I really hope this is working. So I can show you another step in here. I hope this is working. Okay. I hope. Wow, it looks like not working. So I have to increase this one, but just wait a minute. Okay, then let me see if there are some questions. If the package is edited or deleted in RStudio, how do I restore? Why? How can you do? How can you do that? Edit the package. Oh, okay. Thank you very much. This is working. So before I continue, let me see this one. You don't restore it, okay? Okay, thank you very much, Rohit. Okay, now we continue this one. So I already got this one. Okay, so my G sheet is here. You see, okay, and then for this one, I need the expression set here. So now I'm trying to look at the phenotypic of this data set. Okay, so the phenotypic in here is very, very usable, but this one is, I think too many information is here. That's why I just want to look the some of their phenotypic. I already told you that sometime in this information, in this phenotypic data set, there is information that the data set is already been pre-processed or not. Let me show you in here. Okay, here we are. Okay, you can read it in here for data processing. They said that this one already been processed and normalized using this one, using FE package. So in this case, we don't have to do that anymore. Okay. Unless if you are using the raw data set. This raw data set actually not been pre-processed. Okay, then in here, because of this one is too crowded, so I would like to know the dimension of this phenotypic data set. You see 107 and then 41. So there are 41 information about this data set. So what is the name of this information? The first one is about title and geo-accession and so on and so on. The last one is about stage. Okay, so try to memorize, try to remember the phenotypic data set that I already provided for you, which is in Paru p.data.txt before. So you can see from here that actually I don't need most of them in here. So after I look at some information in the previous running, so I only use column 8. In here you have column 8 is mean source name, this one. And then I just also need to use column 38, which is about age at diagnosis. And also I need to know that the patient is cigarette smoking status. They are never smoke, or maybe they are smoking or something like that. And also I need the gender information of this patient. And also I need to know what the stage of, how to say, the stage of the disease. So what is the disease about? This disease about, actually we can have information from NCBI. I already been provided in here, but I forgot to run my LaTeX. Let me see this one. This one, this gene expressions, signature of cigarette smoking and its role in lung, this one, and survival. Okay, so this is about information about the dataset. You can have that from NCBI website. Okay, so because of that, so I just use the phenotypic, which is this one, column 8, 38, 39, 30, 40, and then also 41. So I'm defining the new phenotypic for this data set. I call it as N-pheno. So I just run this one. So I try to look at the information, the new phenotypic that I already choose for this data set. You can see something like this. I think this is more convenient for me. Okay, so you can choose as you like. Okay, so and then now I have to save this phenotypic in text file. So this is the way how I do that. I already share as well with you. So this one, write matrix to file, and this one is n panel. This is I already how to say I already computed in the previous line, and this one is the name of the file that I would like to use to save the the information of new phenotypic data, and then run here, and then now the same like before. So from this line, which is 58, until the last one will be similar with the previous one. Okay, so this is the way how I'm doing analysis by using micro array data analysis. If I would like to do something, how to say that, differentially express gene and also gene ontology. Okay, any question until this point, please? If you don't have any question, and then I will be continuing to the last data set in here, which is about classification. Is anything clear for you? If it is not clear, you can try do it again at home, and then you can send me a message or maybe send me an email to ask some question. That will be okay. Some question. It's quite confusing for me. I'm sorry for this one. Okay. Do you know if you are confused about something, it means your brain is working. So if you are confused, it will be fine. Okay. So don't worry about that one. Okay. Thank you, Alberto and Hussaini. Okay. Okay, my email is in my presentation before. Did you get the presentation file yesterday, Priyanka?
I have shared it with the participants.
Maybe Priyanka not joining the WhatsApp group.
It is.
Oh yeah. Okay, Muhammad Aiman Barudin already shared my email address. Okay. But I think Priyanka is better you are joining the WhatsApp group because you will have another session with different presenter next week. So it's really good if you are you can join this one. Okay. Yes, thank you very much. So if you don't have any question, because the rest will be the same like two previous files. So now we would like to go for the classification with different data sets. Let me close this first, this one as well. Okay. Can you see the file, the last one in here, which is dataset 3? Okay. Yeah. So the same thing like before, you also need to call the library of the package you already installed. If there is some error that say that there is no package like that, so you have to install it. The way you install the package in Bioconductor, they also in Bioconductor website, or you can just go through the presentation file of me yesterday. Okay, so this one I already have my data in my laptop, so I just call the data into our console in here. Run. You can do the same in your computer. So this one class, this one GSE. Okay, you can see that. And then I try to read it by using read FE as usual. Okay, I'm waiting for there, and then I would like to see in the chat box. Okay, you're welcome. Thank you very much. Okay, so now you would like to see. Okay, the same thing like before, FE batch object. Okay, and also the same like before, I need to take the phenotypic information. Okay, hope it is working as well as previous one. Hmm? Mm. Okay, you're welcome. Let me see. I really hope this is working. Mhm. Wow, that's error. So it means I have to increase this one. But that's fine. I mean, this is just the process. Maybe 7. Let me try that again. Hmm. Oh, yeah, the column should be 77, not 76, because the sample is 76 and there is another one information. So this it has to be. Yes, thank you very much. This one, this is the list. Okay, you can see that this is the matrix. I don't need this one. I think this is just, oh. Okay, then, so it has to be G2. But that's okay. Okay. So this one. Okay. Would you like to see the panel? But we will try to look at that later. Okay. So this one, our phenotypic, which is about 42 in here. Okay. So why this is becoming not 42? I mean, this is 43. And then the dimension, this one, okay. So this is the panel, 40 until 55. Okay, yeah. But actually, in this case, we don't need to have this phenotypic as like this. But at least if you would like to do some differential express gene related to this phenotypic data, that we can do that later. Okay, I think we have to use this. We don't need to do this one. Why? Because this is just showing you about the information, the distribution of the data before pre-processing and after pre-processing. But actually, we already know that it has been pre-processed, right? But in this case, I just would like to show you. But this box plot, I don't want to use that in here. So you have to make it in here is G2 because not G7. I will send you the right one later. I'm really sorry about it, but that's okay. Now we would like to see the phenotypic of this data set. You can see from here, this is just the table about the age and the gender. So the gender is a female 22, and then the male about 54, because our data set is 76. And then the stage in here is there is MBAN, MBCL, and so on and so on. How about this data set? This data set, you can go back to the NCBI website. So another one, I think you can just look at here. And this one is the table. Okay. This subgroup is really important in here. Okay. So you can see that from this table, SHH outlier is only 1, and then U is only 2. Okay. So if we are doing this for classification, it is not good. Why? Because 2 is nothing. I mean, it not give you any information. So that's why at the end, we need to remove this classification, this two classification. So at the end, we only use 4 classification, which is about G3, G4, SHH, and WMT. Even we are using this 4, you can see that actually this is unbalanced. So if you are doing classification, so you have to deal with this unbalanced situation. There are some other method or approach or algorithm how to deal with this kind of unbalanced situation. Let me see the chat box, what we have in here. Oh, okay. This one is coming from information of the computer when you are not using line 23. Okay, so you just try to use this one by not using line 23, and then you will get the information from there. I'm not sure, maybe in your computer, not 131,000. I'm not sure, but I guess it will be the same. Okay, so Rahul, you use 24 without 23, and then you will get that number. Okay. Any application also available for genome sequencing? Yes, actually today I would like to talk about RNA sequence analysis introduction, but because of you asked me to explain more about this microarray, so maybe we can postpone it later. I will talk with Parvin maybe later. Okay, so now we are going back here. Okay, so because we know that this is unbalanced, as it is only one sample and another one U, which is only 2 sample, we would like to remove that one. So this is the way how we remove this one by using this one. So I have the new phenotypic without this phenotypic, which is I remove 41, column 41 or 51 and also 67. So in this case, I have the new phenotypic. Okay, you can see it from there. Okay, previously it is about 76. Now, because I removed the sample, which is only 1 and 2, now becoming only 73. Okay, another information about pie chart and so on. So we don't use this one. Okay, it is just information when you are doing investigation or research. Sometimes you have to do a statistical description or describe about your data set. This is the way how you describe this one. So I don't want to go this way. If you want to do that, you can do that later. Okay, so the new data set based on the new phenotypic in here, I think it has to be GSE or GSE2. Let me get back here. No, this is GSE. Okay, so this will be fine. Okay, so this one, run. And also this one. So the previous one, we already read the data, which is the complete one, but this line 98, this is only 73. And then we can check that later. Okay, you can see that number of samples now is 73, but number of gene is still the same as the previous one. Okay, so the previous one, which is FE data, we can try to look at here. Can you see that this is the difference is about 76 about the sample, and then now we are doing pre-processing. Again, actually we don't have to do this one because the data set, the phenotypic data set already said that it has been it has been pre-processed, but we can do this pre-processing. But I think we still need to do that because of we are using the raw data set from the website. If we are not using the raw data set, so we shouldn't do that. Okay, let me run this one. Let me check on the chat box. Yes, maybe next time. I will try to talk with Parvin. Okay, it is already finished. So okay. You see the sample is 73. So this will be okay. This one about the expression. Expression is mean already been in matrix. Okay. Class expression is matrix. And then the dimension, you can see it has to be how many gene, which is on the row, and also the column will be how many samples. I already explained it as well to you. This is the box after pre-processing. If you are doing that before, so you would like to do that again now, that's okay. Okay. After that, we are doing the filtering as like before. You can see that this is the same thing you are doing. Filtering the data. Okay, and then you need to incorporate this filtering into your data sets. So there will be different thing later. Okay, you can see the previous one, the gene is about 54,000 something. But after this filtering, it is only 10,000. You can see the difference, right? Okay, and then this one. Okay, so now we try to prepare for the analysis. I already mentioned yesterday that if we are doing statistical data analysis, usually the row, this is the objects of our investigation, and then the column will be the variable. In this case, we would like to know the relationship between this gene related to this medulloblastoma disease. Okay, so in this case, we have to transpose the data because in bioinformatics data, the row actually the gene, which is the variable in statistics, and then the column will be the sample. But now we would like to use statistical analysis, which is classification. So we have to transpose the data. So in this case, later we will have this one. Okay. Okay. So we would like to do the classification. Previously, there are 6 classifications, but we already removed 2 of them. So in this case, we only use 4 class in this classification analysis. Okay. Okay. Yes. We have to define the factor, the level of the factor in here. So we have 4 levels, G4, G3, this one, and W and T. Okay, that's clear. So now we are doing filtering. In this case, the filtering, I think more to feature selection or variable selection, which is common in classification. So because there are 4 classifications, instead of using t-test, we have to use ANOVA. So in ANOVA, in bioconductor, then in multi-test package, we only use F test, which is in here. I show you that test equal to F. This is the same with ANOVA. If it is only 2 classification, I mean 2 classification, 2 classes, and then we have in here t-test equal to T, because only 2 group. But this one is 4 group. This one, okay. This kind of test, it is coming from MALTEST package, so you have to install it before you use it. Okay, we try to make sure about this one. Okay, so now this is about p-value. Again, we try to how to say, to select some gene. Okay. Okay, let me see that. Okay. Okay. So in this case, we would like to incorporate our filtering into our to data set. So it's become the new data set after filtering. So this is the way how you do that. So this one is the new data after filtering process. Okay, I told you that we have to transpose the data. Can you see this here? So actually our data is data def, but because of it is in bioinformatics form, so we have to transport it and then now becoming the new data for me. Okay. Because we already know that the variable will be the gene, and there are some information from phenotypic data, which is about demographic variable, like for example, age, like for example, gender, and also stage of the medulloblastoma disease, and so on and so on. Actually, this kind of information or variable, we can also incorporate this one into our analysis. But in here, we don't use that because based on our investigation, actually this is not related to something like that. So that's why in here, we don't use this one. Okay, this one. Okay, for classification, in here I'm using SVM, which is support vector machine. And then in here, we are using kernel linear. I mean the hyperplane, it is, we choose it as linear, but also you can choose the kernel maybe non-linear, okay? And then because this is classification, you have to prepare the data training and also data testing. For data training, I'm using 80% of my data set, and then the 20% will be for data testing. Here we go. So this one, I try to choose the turning parameter, which one the best, and after some running. So I'm using the turning parameter is 0.1. You can see on the line 231 in here. Okay. So this is the prediction. Oh, this is still in the process, I'm sorry. Okay, let me see the chat box. Okay, yes, perhaps another time. I will try to prepare that one for you. But actually, if you would like to go browsing in Bioconductor website, you can have also many information related with RNA sequencing analysis by using R, if you want to. We are waiting for the result of this classification. Let me see until which line this one. 265. Okay, just a little bit more. But my computer may be not really good, so it is run slowly. I made some adjustment in this file. I think I had to send the revision file to Parveen, and then Parveen will send the latest revision to you later. Okay, we are waiting for the result. Let me explain about another line. So in here, in line 20 to 233, actually would like to show the table prediction, which is like confusion matrix. So we try to matching about the prediction based on the model and also the real situation. It is based on the dataset for testing dataset. And this one, 235, it is computing the prediction based on the data training. Okay, mean 237, this is about the mean of prediction based on data training here, okay? And then for this one, it is just the plot, okay? So you can see about the result in here. And then for 248, it is about ROC, which is we try to show you how good actually the model based on the dataset, training dataset. And also you can have the information or the value about AUC. AUC is mean area under curve, which is showing you if it is, for example, close to 1, maximum is 1, and minimum is 0. If it is close to 1, it means the model based on your data set, actually this is very good for prediction of classification. For example, you have the new data set, so you can be sure that this one classified is right, okay? But if your AUC, for example, less than 0.6, I guess, so you have to consider, maybe you have to use another model. In here, we are using a linear kernel. Probably your kernel or your hyperplane to divide it between this classification, this class. It is not exactly linear. It may be non-linear. Then you can use also different type of non-linear kernel. Okay. And then 256. So based on this model, we can also do the gene profiling, which is we try to get the information actually which gene which is the most contribute to this model. If, for example, the classification is only 2, for example, normal and then normal and cancer, for example, normal and cancer. So we would like to know which gene actually contribute more or related more into this cancer, medulloblastoma cancer. So in this case, we can select the most 10 most gene which is contributes to this disease. So that's why in here I'm using the gene profiling. Okay. And after that, we also can relate this gene, which is the most contribute or the most related to this disease, into this, how to say, the database based on the human genome database. Okay, so we can know about the gene name, we can know about the symbol, and we can also know about the probe ID. The probe ID, which is coming from Affymetrix platform. So actually, that's all. We're still waiting for the result. I'm not sure, maybe my computer working slow. working slowly. But actually, that's all that I would like to how to say explain to you how to use the microarray data analysis by using bioconductor. Okay, so in this case, bioconductor is developed by using R programming language. So you have to understand a little bit about R. If you can do programming, it will be better. But if you cannot do programming, it is still okay, because there are a lot of people will help you in support side of bioconductor. And also, I think there are some people already put some code in GitHub, so you can directly browsing in there. Just need to be patient a little bit because we have to do browsing many times, and then we can get what we want to, which is, for example, suitable for our how to say problem maybe. Okay. So this kind of classification data analysis, in this case, you have to understand a little bit about statistics, because when we would like to, for example, doing analysis by using this classification SPM. So in this case, you are dealing with some concept about metrics and also some concept about uncertainty in here. But if you don't understand about this support vector machine or classification data analysis, other method, it is okay as well. Why? If you are a biologist, I mean, if you are not mathematician or statistician in background, so it is it doesn't have to understand in detail about this approach or this method. But if you are coming from, for example, mathematics or statistics or computer science, I think because you need to do the programming for the computer science, so a little bit understand about statistics, it will be better. Okay. We are still waiting for, but I'm not sure why this is so long. It should be not too long. So should we wait until the result, Parveen, or I'm not sure. But I'm
Rohmatul,
yeah.
so
I'm looking to how to say to waiting for the result, but I'm not sure why this is working slow. Maybe about the data.
so this is the last step, or any further step?
There are some other in here, which is we only until line 234, but the last step will be 265. But I already explained that one, so they can have how to say practicing at home, and then they can get back to me why this is not working. If, for example, but if it is
so
working,
what can we do? We can end.
For me, it's okay. I mean, I can report if it is working in our WhatsApp group.
Okay,
So,
okay. That will be great.
Yeah, if it is not working, and then I will inform as well, and then I will how to say send you the latest revision. This is working. Okay, thank you very much.
Okay.
I think the computer needs to be scolded a little bit. Okay. Okay. So I think it's better we are doing we are running this code first, and then we can get back later. So the participant can understand that actually this is working. Okay. So in here, the prediction is about 0.86. I think this is about 87%. So our model, based on this kernel linear for doing prediction of classification, still okay. So this is still good, I mean. Okay. Yeah. Okay. Wow, this is very good, but this is because this is data training. Okay, now let me see. Okay. Actually, I don't need to view this one. So I just would like to close it. Okay. Now this is about ROC, which is about the AUC value. Okay, you can see that the AUC was 0.95. So this is still very good. Yeah, I mean, I show you something good, but if I show you something not good, maybe you are not interested to do the classification. But this case, I mean, this is very good. Okay. I don't want to see the ID. Okay, no problem. Okay. Wow, this is wrong. Select apply to an object class annotation. This one, this one, this one. But that's okay. It doesn't matter. I mean, this one, it is not important. Yeah, okay. At least we have information that actually the model that we are using in this classification is very good model. And we can sure, for example, if we have the new patient with this with this kind of information, we are sure that this patient can be classified into 4 classes. Okay, we already have that classes before. So in the future, for example, you have your AUC below 0.6, so you have to reconsider to use another method or to use another approach. Maybe the kernel should be non-linear. You don't need to stick that the kernel is linear. Even in this exercise, the kernel is linear, but there are different kind of kernel or hyperplane. Thank you very much. I think that's all for me. If you want to know about the error, I will get back to you later in our WhatsApp group. Okay. Thank you very much, Parveen, and also the participant who's really, really patient, waiting for the computation, which is very, very slow in here. Again, thank you very much.
So thanks, Rahmatul, for such a nice session. You shared your knowledge, experience with our participants. So hopefully we will again invite you in the future.
Yeah.
Our workshops, that is our aim to provide affordable bioinformatics globally. So thanks. And now I will seek your permission for ending today's session.
Okay, thank you very much. See you another
Hello,
time.
doctor. Hello, doctor.
Yes.
Yeah, this bioconductor is it basically for MSc or for PhD classes?
I think I'm not sure. It is maybe for master, because for PhD you have to develop the new one. This is not the new one. Okay, for PhD you have to develop the new method, the new approach, maybe the new databases, something like that. Okay, but this is maybe suitable for undergraduate and master, but it is very useful in your research. Okay.
In research.
In your research, in data analysis for biologists or medical or chemistry, but not for mathematician or for statistician.
Okay, like someone that's doing a project that wants to do project in bioinformatics.
Yeah, for bioinformatics project, if you, for example, now you are working on plants bioinformatics, and then you are moving to another, which is for human bioinformatics, different organism, different species. So you can apply this method to another one. So for this is useful for research. So research is not for undergraduate, not for master, but for all. Okay.
Okay.
Yeah.
I'm finding it so difficult to follow up.
You can ask me later. You can send a message or you can send an email. It doesn't matter. If you have any question, please let me know. Okay.
Okay. How can I see your email?
Yeah. I already, how to say, share my email.
I have shared your PPT in the WhatsApp group, and I will share your email on the WhatsApp group so that more and more people get to know about your email. Okay.
Okay. Ayman already sent about my email address on the chat box.
Okay. So
Okay.
thanks,
Okay.
Rom. So
Thank you very much.
we are already running with time. So
Yeah.
thanks again, and thanks
Thank you.
participants for listening us.